And what is up to our spaced out viewers? Thanks for tuning in. Congratulations on realizing our channel exists. Welcome to the smAsh News Network, least busted name in news. Let's get spaced out. So we're looking at the sun here from the Solar Dynamics Observatory to see a large sunspot setting in the northwest. That's sunspot 2882. And if no new sunspots form, we'll have a 0 sunspot day coming up here momentarily. Most likely spot for sunspots to occur at this moment would be up here in the northeast, in my opinion. There is still a coronal mass ejection warning in effect. Let's go out to Lagrange point 5 and take a look at the viewpoint from stereo A. You can look at it yourself if you like on the Integrated Space Weather Analysis Center. It's page 7 on the Solar tab. Stereo A Core 2 Space Weather Beacon, the Stereo A coronagraph. We look at it regularly. And we are expecting a far side coronal mass ejection and an earth side coronal mass ejection in the next 24 to 36 hours, we'll say. So the first thing you're going to see is a coronal mass ejection on the opposite side of the sun and then one on the earth side. That's my word. Let's take a look at the colorized magnetogram here before we continue on. So we've realized we can forecast coronal mass ejections about 8 months ago, and our accuracy has been as close as you could possibly get to 100%, as we only missed one forecast, and it was because of lowering a watch. So we had a watch in effect, we lowered it too quickly. That happened very early on. We've had 0 false alarms and 100% success except for one missed forecast. If sunspots are going to occur, they're going to occur up here. That's the most magnetically organized region on the Earth-facing portion of the solar disk. Here it is in 304 angstroms, ionized helium from the SDO. 2 majorly well-defined coronal holes rotating into the Earth-facing zone here. You can see one up here in the north, one down here in the south. They're not always visible in 304 angstroms, but these are well-defined. You can also see some ejecta, or some filamentary movements happening up here, right there. Right at that moment, you see some filaments moving around. 304 angstroms is great at showing those. Let's blast through more data. The radial flux down to 84. Here's the 1-year chart of the 10.7 centimeter radial flux. The black line here, the red line is the sunspot number, which is dropping down to 0. Low levels of solar activity, folks. So we do see geomagnetic unrest forecasted here for October 18th, late in the day. That's the onset of a coronal hole wind stream. Again, 2 well-defined coronal holes facing Earth. Let's take a look at global seismicity. And Cumbre Vieja volcano has produced a 4.6 magnitude earthquake. We'll get to it in a minute. It's the largest quake produced by the island. Anyway, just going to scroll up the list here. No major quakes. Global seismicity is rather low at the moment. There were some deep quakes like this, 4.5 at the Philippines. Estimated depth 111.7 kilometers. Indonesia also saw a deep quake at a 4.3 magnitude, 282 kilometers depth for that one. Again, no major quakes over the past 24. A quake off the east coast of Siberia here, a 4.9 at depth. That's 142 kilometers estimated depth. Argentina saw a deep quake. That's 4.2 magnitude, 116 kilometers estimated depth. Another deep quake here in Argentina, southwestern South America there. That's a 4.6 at 145 kilometers estimated depth. Continuing on. So here's the largest quake that La Palma has produced since this most recent eruption here. That's a 4.6 magnitude quake, which occurred, I think, 37 kilometers below Cumbre Vieja. So that's pretty serious. There is some speculation and argument about what this means. The volcano's been producing a 14,000-foot ash plume, and the amount of outgassing has actually increased here. The eruption has switched to dominantly effusive. So we may see the most gassy magma at the top of the magma chamber now. And again, it's up to debate as to what that means. But that 4.6 magnitude quake was felt all over the island. and the largest so far quake occurring at 5:41 just this morning, just a couple of hours ago, folks. Suwadose-jima also producing a 6,000-foot ash plume there over the Ryukyu Islands. Mount Ibu on Halmahera, Indonesia, exploding 7,000-foot ash plume. Fuego exploding on Guatemala. 15,000-foot ash plume as Guatemala gets fertilized by volcanic ash. Yes, volcanic ash, it's great fertilizer, folks. Sangay in Ecuador, no volcanic ash observed in satellite. Don't assume it's not erupting. Revenador exploding, 16,000-foot ash plume over Ecuador from Revenador. Sabancaya exploding, 26,000-foot ash plume over Peru. And Novatos de Chilean exploding, 14,000-foot ash plume. Please don't pole vault the caldera. Please do visit our links. Support the channel via the links below this video. One of the links you can find is to the smAsho merch shop, our Redbubble store. You can also find links to this on the homepage at smAshomash.com. Just click smAsho merch, and you'll be able to find this. Today's featured product is the smAsh team, and I'm actually wearing a slightly different design here. Let me show this off. Yeah, the smAsh team. In 2018, a crack YouTube unit was sent to social media prison for a crime we didn't commit. We promptly escaped a maximum social media stockade into the internet underground where we survive as producers of fortune. If you have a problem, if no one else can help, and if you can find our channel, maybe you can hire the smAsh team. Now, the design I'm wearing is the complimentary merch for becoming a paid-up member at smashomash.com/smashTeam. But we've decided to include this even though you can't buy the design I'm wearing unless you sign up for a 1-year annual membership. It's $109.89 a year. It gives you a free month and the complimentary merch. Continuing on, welcome to the Neo Renaissance, by the way. Here's our homepage at smashomash.com. Let's talk briefly about our mission. You may have heard of our mission. You can read about it yourself if you like at smashomash.com/forum/mission. It is to assist, study, and report on the ongoing formation of a unified theory of physics, to raise the awareness of the general public of the relationship between space, weather, and Earth effects, to connect and consult with media organizations and multiply our reach. Even though the YouTube algorithms don't seem to be helpful with that. 4, to demonstrate cutting-edge proof-of-concept solutions to problems. To publish scientific papers in a multidisciplinary manner, including but not limited to sciences like spectroscopy, chemistry, astrophysics, health, wellness, longevity, cosmology, biology, magnetohydrodynamics, geology, etc. To assist mankind by advancing the study of predictive phenomenon in order to optimize value and reduce risk and liability and save lives and resources and adapt no matter what the adversity is. And lastly, but not leastly, to not be ossified in our beliefs and to treat those who are with love, respect, and inclusion to the scientific discussion. Sometimes it takes people a lot of time to catch up. Let's take a look at magnetic data here, as in some ways it is the most predictive factor in forecasting what the sun will do next. Anyway, here's the GOES magnetometer over the past 3 days, and we're seeing some pretty significant spikes here. Between the GOES 16 and 17, you can see some disparate readings happening there. That's the GOES 16 and 17 magnetometers. Next, the ground-based magnetometers and magnetometers on stereo A and stereo B. The National Sunspot Observatory creates this graphic. It's the top view ecliptic plane field plot. Earth is just in a South Pole current sheet at the moment, and I would expect Earth to stay there even if sunspots do form in the northern hemisphere. That's my stance. Here's the line of sight view of the same data. Essentially, it also shows you the solar magnetogram. And here's the line of sight coronal hole plot. You can see those 2 coronal holes there that are in the Earth-facing zone at the moment. The northern one is North Pole oriented, and the southern one is South Pole oriented. And look how large the south coronal hole is. It's quite a well-defined and large coronal hole system, although not reaching up over the equator. Here's a better visualization of it in 193 angstroms from the SDO. Some interesting plasma activity right here also. You can see some plasma sort of spilling its way up toward the North Solar Polar Crown. Interesting plasma reorganization going on up there as the sun attempts to reach static equilibrium. There still is a solar flare warning in effect, folks, as we could still see major flares from sunspot 2882 even after it's out of view, folks. You don't need a sunspot in view of the Earth to produce a major flare. So we're going to have to keep our coronal mass ejection warning and our solar flare warning in effect, at least until tomorrow's video. Next, looking at some more data here. Here's the GOES X-ray flux. No major flares over the past 3 days here. Just some minor C-class intensifications there in the X-ray flux. No spikes in the proton flux period. No coronal mass ejections yet headed our way. We'll keep you posted on that. Let's look at the real-time solar wind here. Pretty unremarkable over the past 24. Solar wind density, 7.5 protons per cubic centimeter. Solar wind speed, just over 400 kilometers per second. KP index at 1, geomagnetically calm conditions. Each bar representing 3 hours there, folks. Here's 4 hours of data of magnetohydrodynamic pressure as calculated by the Space Weather Modeling Framework. Fairly consistent pressure here over the past 4 hours, the time frame reflected in this geospace magnetosphere movie. Next, ground magnetic perturbations. We show it daily since there's a polar excursion going on and some people are unnecessarily frightened about it. There's 4 hours of data. This is nanotesla. The last imagery was nanopascals, magnetohydrodynamic pressure. Nanotesla is magnetic flux density. Ground magnetic perturbations, geospace delta B changes to Earth's B field over the past 4 hours. Next, a diagram of the solar system. We like people to know where things are and where they'll be in a week. And there's where they'll be on the 23rd. Here's a star chart. Today the sun will be passing through Leo and Gemini and Taurus. I don't know if that means anything to you or not. It doesn't mean very much to me as I'm not an astrologer. But in any case, the yellow line here is the ecliptic. The blue line is the galactic plane. And my star chart faces the south as I'm facing the south. Today's cosmology segment's got to be brief. I want to talk briefly about Cygnus X3, but first, the gates of hell. The gates of hell crater has burned in the Turkmenistan desert for 50 years. When some equipment collapsed into a sinkhole, and it's been burning ever since. Quite an interesting and weird place. What's interesting about this, and the reason it appears in our cosmology segment, is because some guy went down there, the only person known to have ever entered the gates of hell crater, to look for extremophiles. Yes, extremophiles. Bacteria that live on chemosynthesis instead of photosynthesis, surviving on methane. Are there extremophiles in space? Leave us a comment and let us know what you think. Yeah, he found extremophiles down there. I don't know why he wanted to look for them, but anyway, he went down there and he took samples and discovered that indeed there were extremophiles. If you want to read about it, you can read about it on AccuWeather.com. Or just do a search for Gates of Hell crater has burned in remote desert for 50 years. Today's random number is not going to be a thing. We're looking at Cygnus X3, and I wanted to just note something here about the historic chart. The 16-year chart right here, folks. You see this sloping down? This is actually the longest quiescent period that we've seen since 2006 from Cygnus X3. So we're interested to see what happens next with Cygnus X3 here. Maybe we're viewing some tiny portion of a larger cycle. What's interesting about Cygnus X3 is that it's one of the only known cosmic ray point sources. If you want to follow the hard X-ray outputs from Cygnus X3, which is associated with the star called Deneb, the tail of the swan in the constellation Cygnus, just head to the Neil Gorell's Swift-Bat X-ray Observatory and do a search for CYG space X-3, and you'll find Cygnus X3. It's entry number 948. the high mass X-ray binary. And we're interested in some radio astronomy on this when it's in its quiescent state, but also especially when transitioning from its X-ray loud to X-ray quiet, or better yet, X-ray quiet to X-ray loud, as we see now. It might give us insight into the giant plume of plasma that's connecting this star and planet Earth from like at least 1,800 light years, possibly as much as 4,000 light years distance. It's tough to tell the distance to an object like that. Today's astronomy picture of the day is the Mona Lisa. Yes, the Mona Lisa. If you look at the images in the lower right, the zoomed out images, you can see all of these images have been arranged in such a way. They're unfiltered, by the way. Those variations in the moon color are associated with the atmosphere and with Earth glow, an effect that Da Vinci talked about over 500 years ago. So that's the astronomy picture of the day. You can go check it out yourself if you like at apod.nasa.gov. The Mona Lisa. That's today's cosmology segment. We kept it brief. Don't forget to check our playlists for hundreds more cosmology segments. We've got like 230 separate videos in our cosmology segments playlist, youtube.com/smashamash/playlists. All right, let's blast through even more data. How about some satellite charging hazards? We ain't got none. Here's a one-year chart of the relativistic electron flux. You can find that at solon.info if you like. solon.info/solar for all that data. Here's a 3-day chart. We didn't quite make it into warning levels yesterday. That 3-day chart measured by the GOES 16 and GOES 17 satellites. And here's the forecast model. No arguments there. The green boxes are the forecast. The yellow diamonds are the observation. Here's a diagram of Earth Van Allen belts because we're going to show you the total electron content forecast. And the redder you see blobs here, the more likely GPS errors are to occur in those areas. We're seeing fairly well organized inner Van Allen belt at the moment. Nothing to write home about there. Here's another diagram to show you where the Ionosphere layer is because we're showing you the ionogram next. The ionosphere, located at about 300 kilometers of altitude, is in many ways the bridge between space and Earth. There are a lot of chemical reactions going on up there, and it's creating vibrations. Those vibrations are measured by the Australian Government Bureau of Meteorology and represented in this ionogram. Each color gradation there you see is a variation of 1 megahertz, 1 million vibrations per second. The graph showing 1 to 14 megahertz. There's the latest image from 10:15 Universal Time. And here's the anomalygram. So this is the departure from the 30-day median in megahertz. Low-frequency anomalies occurring over North Africa and the northern Indian Ocean, as well as North America, as it descends into winter. And the southern hemisphere ascends into summer. Or you could say the sun is ascending to the highest point in the ecliptic when they see their solstice. Anyway, here's the latest anomalygram. That's also 10 o'clock Universal Time. And some low-frequency anomalies happening here at the Philippines at the moment. Do you watch our meteorology segments? If not, they usually premiere before the daily space video. Before the daily space weather video. Check them out. There's a playlist for those too at youtube.com/smashamash/playlists. All right, let's do it. Here come bonus features. This is the Udaipur, India ground-based solar observatory showing you hydrogen alpha imagery of the closest star, El Sol, Helios, the sun. Keep in mind the data here is just over 3 minutes old. Coronal mass ejection warning stays in effect. Solar flare warning stays in effect. So here's the latest intensity gram to see the final setting mode here of sunspot 2882. And if no additional sunspots form, we'll be back to 0 sunspots. Most likely place for sunspots to form is right up here. There are the magnetic fields of sunspot 2882. And we'll close out with some composite imagery here. Here's the southern hemisphere. This is 304 and 171 angstroms composite. You can see some filaments down there in the southeast and the southwest. Here's the northern hemisphere, and you see filaments around here as well. Some of those are going to blast off and exit the solar corona in the next 24 to 36 hours. And we'll close things out here with sunspot 2882. The most interesting feature on the sun over the past couple of weeks. In any case, thanks for tuning in. Congratulations on realizing our channel exists, and may that solar wind be at your back.